Hi friends, in this video we are going to discuss about speed equations. In speed equations, we have to know the formulas. First one, ns is equals to 120 f by p, f nothing but supply frequency, and slip s is equals to ns minus nr by ns. From this, rotor speed nr is equals to ns into 1 minus s, ns into 1 minus s. Next, rotor frequency for positive sequence, s into fs. Rotor frequency for negative sequence, 2 minus s into fs. And full load slip speed, ns minus nr. If we multiplied and divided with ns, is also written as s into ns. So full load slip speed ns minus nr, nothing but full load slip speed ns minus nr, nothing but s into ns. These are the speed equations, very important. Okay, now let's go for rotor analysis. First one, in rotor analysis, my rotor resistance is R2, my rotor reactance is X2, my rotor EMF is E2, my rotor current is I2, like that. Generally, resistance independent of frequency, but reactance depends on frequency because this is 2 pi FL. Reactance depends on frequency, resistance independent of frequency. And next one, E2, EMF. Generally, EMF E is equals to what is formula? Like a transformer. What is EMF? For example, EMF for first winding or stator winding or primary. E1 is equals to 4.44 into 5 into F into N1 into Kp into Kd. N1 is the primary number of turns or stator number of turns. If we are using E2 is the secondary number of turns or rotor EMF is equals to 4.44 into 5 into rotor frequency. This is the stator frequency, this is the rotor frequency, N2 into Kp into Kd. Nothing but EMF also depends on frequency. The resistance independent of frequency, reactance depends on frequency, and EMF also depends on rotor frequency. EMF also depends on rotor frequency, and current I is equals to E2 by Z2. The current I is equals to E2 by Z2. Like that we have a different. Okay, have an idea. The rotor resistance independent of frequency. The rotor reactance depends on frequency. This is rotor frequency. The EMF, this is for stator EMF, and this is for rotor EMF. Rotor EMF depends on rotor frequency, and current I is equal to E2 by Z2, and power factor cos pi is equals to R2 by Z2. Power factor cos pi is equals to R2 by Z2. Like that we have a different. Right? Let's do the analysis, rotor analysis. We have a rotor parameters, we have to draw those values. Before that, at starting nothing but what is NR? NR is equals to 0. At starting, that's why NR is equals to 0. If NR is equals to 0, what is slip? NS minus NR by NS. What is the value? The slip value 1. Slip 1 nothing but 100% slip out. 100% nothing but 1, right? 100%. 100%. Cent nothing but 100, right? 100% nothing but 1. So here when starting condition NR is equal to 0, 100% slip, S is equals to 1. But at running condition, rotor speed is NR and rotor frequency FR and slip S. Here rotor frequency is equals to, what is the formula? S into Fs. What about at starting condition rotor frequency? At starting condition rotor frequency, S into Fs. What is S for starting? For starting, S is equals to 1. For starting, S is equals to 1. That's why Fr is equals to Fs for starting. And Fr is equal to S into Fs for running. Because at running, the speed is NR. At running, the slip is S. At starting, the speed is 0. At starting, the slip is 1. At starting, the slip is 1. Right? These are the rotor analysis. Now we have to draw in neat, in a particular manner. Let's see how they are. Let's see once. See here. The rotor analysis is the rotor analysis. In this, the rotor parameters. These rotor parameters, what are the rotor parameters? One is the rotor frequency, and second one is the rotor resistance, and next one is the rotor reactance, and next one is the rotor impedance, and next one is the rotor EMF, and next one is the rotor current, and next one is the rotor power factor, and next one is the rotor circuit. Okay, these are the rotor parameters. Rotor frequency, rotor resistance, rotor reactance, rotor impedance, rotor EMF, rotor current, rotor power factor, rotor circuit. These are at a standstill condition. At standstill, nothing but NR is equals to 0. If NR is equal to 0, what is the slip? Slip is equals to 1. At standstill condition, NR 0, slip 1. At running condition, rotor speed is NR, slip is S. Running condition, rotor speed is NR, slip is S. Now tell me, what is rotor frequency at starting condition? Rotor frequency Fr is equals to S into Fs. S is equal to 1, that's why Fr is equal to Fs. But at running condition, Fr is equals to S into Fs. Right. At starting condition, what is my rotor resistance? The rotor resistance is same for starting and running. Standstill and running, because the rotor resistance independent of frequency. Now, rotor reactance at starting condition X2, but at running condition S into X2, because it depends on frequency, 2 pi FL. F nothing but S into Fs. Next, impedance. Impedance is equals to square root of R2 square plus X2 square. But at running condition, square root of R2 square plus S square into X2 square. S square into X2 square. EMF E2 is the same for starting condition, because S is equal to 1. But at running condition, S into E2. At running condition, S into E2. What is I2? I2 is equals to E2 by Z2. I2 is equals to E2 by Z2 at starting condition. At running condition, S into E2 by Z2. This is at running condition. Power factor. Power factor is equals to R2 by Z2. R2 by Z2 at starting condition. At running condition, R2 by Z2. R2 by Z2. S square, X2 square at running condition. Right? This is the power factor at starting at running condition. This is the current at starting and running condition. This is the EMF at starting and running condition. This is the impedance at starting and running condition. This is the reactance at starting and running condition. This is the resistance, same for starting and running condition because independent of frequency. This is rotor frequency at starting and running condition. At starting and running condition. Okay, these are important. You have to remember all these. You have to remember, especially this one. They are giving at starting condition rotor reactance, and they are giving the slip value. Then find out reactance at running condition. Like that they are asking. For example, question asking like this. In your induction machine, at standstill, reactance 10 ohms. At running condition, my slip is 10%. At running condition, my slip is 10%. Can you tell me the rotor reactance? What is rotor reactance at running condition? S into X. What is X? 10%. 10% S value. What is X value generally? 10. So what is answer? What is answer? X is equals to 1 ohm at running condition. It's a very simple question. Yes? At standstill condition, X value 10 ohms. My motor is running at slip of 10%. Then what is rotor reactance? Rotor reactance is equal to S into X. What is S? They given 10%. 10 divided by 100. 10% nothing but 10%. Cent nothing but 100. S into X. What is X value? 10. 10 by 100 into 10 nothing but 1 ohm. Like that they are asking the questions in competitive exams. Right? Next one. These are the different questions they are asking in competitive exams. Now, circuit. We have to draw the circuit. We have to draw the circuit. How it will the circuit? The circuit is like this. The circuit is like this. Here the EMF is E2. And here the current is I2. And here the rotor resistance R2, rotor reactance X2. At starting condition, E2, I2, R2, X2. At starting condition. But at running condition, my EMF is S into E2. At running condition, EMF is S into E2. My current is I2. My resistance is R2. But my reactance is S into X2. Nothing but this is variable. This is not a fixed value. This is variable value. Because when speed changes, slip automatically changes. When speed changes, automatically slip changes. Why speed changes? When load changes, speed changes. When load changes, speed changes. When speed changes, slip changes. When slip changes, reactance changes. That's why this is variable value. So S into E2, I2, R2, S into X2. S into X2. Right? This is the rotor circuit for standstill and running condition. Rotor circuit for standstill and running condition. Right? Now we have to take this one. Take this one here. Take this one. Now my rotor circuit is like this. My rotor circuit is like this. Here have S into E2 and here I have R2, here I have S into X2. For this current I2 is equals to S into E2 divided by square root of R2 square plus S square X2 square. Right? Take the common, S common. I2 is equals to S into E2 divided by, if S square gets outside, its value S square root of, tell me what is the value? R2 by S whole square plus X2, S gets cancelled. Now tell me finally I2 is equals to E2 divided by square root of R2 by S whole square plus X2 square. For this I have to draw the circuit. For this I have to draw the circuit. Tell me how the circuit will be. The circuit will be like this. What is EMF here? The EMF is E2. What is reactance here? X2. What is resistance here? R2 by S. What is current here? I2. Current is I2. Actually, these two are the same circuits. Just I modified. But both are equivalent only. Both are equivalent only. So, E2, I2, X2, R2 by S. Now, I'm doing that. I'm writing here, it's equivalent another circuit without any variables in the winding. Without any variables in the winding, I'm drawing its equivalent circuit. Let's see how the circuit. For example, this is my R2 and this is my X2 and this is my E2 and this is my I2. I'm taking R2, I'm taking X2. Sir, here some variable resistance should be there. Yes, I have a variable resistance here. This is I'm taken as load resistance RL. I'm telling that these both are the equivalent. What is the condition to equivalent these two? What is the condition? Tell me. What is the condition? If both are equal, what is the condition? See here, E2 is there, both are equal. I2 is there, both are equal. X2 is there and X2 is there, both are equal. But here I have R2 by S, but here I have R2 and RL. If both are equal, nothing but what is the formula? R2 by S is equals to R2 plus RL. Both are equal. To get both are equal, R2 by S is equals to R2 plus RL. R2 by S is equals to R2 plus RL. This is the important, very, very important. Generally, now my aim to find out the load resistance. That's why I came here, up to here. My aim to find out the load resistance. Now, can you tell me what is the load resistance for my machine? Tell me, R2 by S is equals to R2 plus RL. I want RL. RL is equals to R2 by S minus R2. RL is equals to R2 into 1 by S minus 1. This is the formula, very, 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 very important. The load resistance of the induction machine. Depends on the circuit resistance as well as depends on slip. Load resistance also depends on slip value is very important formula. Very important point. So load resistance is equals to the secondary winding. a rotor resistance into 1 by S minus 1 is very important formula, is the load resistance, very important formula. Finally, we got formula for load resistance. The load resistance RL is equals to R2 into 1 by S minus 1. R2 into 1 by S minus 1. R2 into 1 by S minus 1 is the very important formula for us. Right? Actually, here started. This is actually circuit. From here, modified circuit. From here, equivalent circuit. From this equivalent circuit, I confined my load resistance. My load resistance RL is equals to R2 into 1 by S minus 1. Is it okay? Understanding or not? Right? This is very important.